Welcome to the Astro Guy podcast. I'm your host, Wayne Zuhl. The last couple of months haven't had that many good nights for observing or imaging, but when the skies cooperated, we did have some pretty good nights. Now, as March roars in, we're experiencing later sunsets and the nights are getting shorter. Soon the warmer weather will be here, along with many of the wondrous sights that are seen on March evenings. Spring is unofficially known as galaxy season, so this month we'll explore some fun galaxies in Leo. There's a lot happening in the skies this month, so let's get right into it with our Planetary Roundup. Mercury puts on a pretty good showing in the evening skies as March begins. On the 1st at 6:30 p.m., Mercury will be about 7 degrees above the western horizon, glowing at magnitude minus 0.95, and its disk spans 6 arcseconds across. On the evenings of the 8th through the 10th, Mercury will be almost 11 degrees above the horizon at 6:30 p.m., but the planet will have dimmed to magnitude 0. On these evenings, you can use nearby Venus to help you find Mercury. Venus will be about 3.5 degrees above and to the right of Mercury. However, by mid-month, Mercury will have faded and receded into the twilight glow, making it too difficult to spot. Venus, which has been putting on a great show the last several months, is quickly exiting the evening skies. At 6:30 p.m. on March 1st, Venus will be glowing brilliantly at magnitude minus 4.79 and will be about 20 degrees above the western horizon. It will be showing a 14% illuminated crescent that spans nearly 50 arcseconds across. Also on the 1st, the 5% illuminated crescent moon will be about 7 degrees below and to the left of Venus. Binoculars will help you to spot the very young moon in the twilight glow. Venus is rapidly receding towards the horizon each evening, and by the 18th, it too will be lost in the twilight glow until it reemerges in the morning sky next month. Mars is very well placed this month for evening observers. On the 1st, Mars rises a little before 1 p.m. and transits the meridian at 8:34 p.m. while setting at 4:18 in the morning. It is shining at magnitude minus 0.25, and its disk spans almost 11 arcseconds across. It's easy to locate as it forms a triangle with the twins Castor and Pollux in Gemini. By the end of the month, Mars is transiting a few minutes after 8 p.m. and setting at 3:39 a.m. The planet has faded by more than half a magnitude, but it's still bright at magnitude 0.38, and it appears smaller, spanning just over 8 arcseconds across. As spring goes on, Mars will continue to fade and appear smaller, so get your views of ruddy Mars in while you can still spot details on the planet. On March 8th, the 10-day-old waxing gibbous moon will be a little more than 1 degree away from Mars, making for an interesting spectacle. This should be a real treat in binoculars or a scope at very low power. Appearing more yellow-orange than Mars, Jupiter spends all month in Taurus the Bull. On March 1st, Jupiter transits the meridian at 6 p.m. and sets just before 1:30 in the morning. The planet is shining brightly at magnitude minus 2.29, with its disk spanning more than 39 arcseconds. By the end of March, Jupiter will transit the meridian at 5:18 p.m. and set a little before 1 a.m. It will be slightly fainter at magnitude minus 2.1, and its disk will span 36 arcseconds across. On the evening of the 5th, you can spot the moon about 7 degrees west and 4 degrees north of Jupiter. On the 6th, the moon will be about 9 degrees east and 4 degrees north. With the naked eye, this should be a gorgeous sight. Even using binoculars, you can make out the disk of Jupiter and easily spot the 4 Galilean moons, but you'll really need a telescope to spot details like the equatorial bands or the Great Red Spot. Jupiter is well placed all month long for evening observers, but it will be receding further west each night, setting a little earlier. So get your Jupiter views in now before it becomes more difficult as spring goes on. Both Saturn and Neptune are lost in the glow of the sun all month long. However, Uranus is well placed this month for evening observers. Uranus spends the first 2 days of March in Aries, and it moves into Taurus on the 3rd. On the 1st, Uranus transits well before sunset and sets at 11:52 p.m. It is glowing dimly at magnitude 5.79, making it visible to the naked eye under extremely dark moonless skies away from city lights. It's much easier to see with binoculars, where it appears as a bloated, pale bluish star. Spanning only 3.5 arc seconds across, you really need a telescope at high power to see the disk of this cold, distant world. By the end of March, Uranus sets at 11 p.m. It's slightly fainter, at magnitude 5.83. Its diameter hasn't noticeably changed, however. By the 3rd week of April, Uranus will be tougher to spot as it moves into the evening twilight, so get your glimpses of it in now. Now, I'm about to use the term universal time, or UT, which is the standard timekeeping system used in astronomy and other sciences to keep things consistent across the globe. It's based on the rotation of the Earth and is essentially the modern version of Greenwich Mean Time. When astronomers talk about events like eclipses, planetary transits, or meteor showers, they use UT so that no matter where you are on Earth, you can convert it to your local time. Now, on March 20th at 0901 Universal Time, the Sun will cross the celestial equator moving north. This is the start of spring in the northern hemisphere and the beginning of autumn in the southern hemisphere. As you can see on this diagram, in the northern hemisphere during summer, we're further away from the sun than we are in winter. So why is it warmer when we're closer to the sun? The reason is because the Earth's seasons aren't determined by how close we are to the sun, but by the tilt of the planet's axis. During winter in the northern hemisphere, Earth is actually closest to the sun, but the tilt causes sunlight to hit at a lower angle, spreading its energy over a larger area and making it colder. Conversely, in the summer, even though Earth is further away, the sunlight is more direct, leading to warmer temperatures. At the equinox, both hemispheres of Earth receive sunlight equally, creating nearly equal amounts of day and night. While it's often said that day and night are exactly the same length, that's not quite true. Thanks to the way Earth's atmosphere bends light and the way we define sunrise and sunset, the day is actually a little bit longer than the night. An interesting event will take place on the evening of March 13th, going into the 14th, as the Americas will be well placed for a total lunar eclipse. For those of us in the Eastern time zone, the penumbral phase, or the faintest part of the shadow, begins at 11:58 p.m. on the 13th, so it's going to be a late night if the skies cooperate. In the show notes, we have a link to a page where you can get the timings for your location, but I'll use universal time to describe the eclipse. The penumbral phase begins at 03:57:28 UT on March 14th. During this part of the penumbral phase, the Earth's penumbra starts to traverse across the face of the moon. This subtle shading is often hard to notice, but keen-eyed observers sometimes can detect a slight dimming of the moon. The partial phase begins at 05:09:40 UT. The moon is now entering the Earth's umbral shadow. As it makes its way across the surface, it creates a visible bite as the darkness covers the moon. The first minute or so, it will be tough to notice, but in a telescope or binoculars, you should detect the dark shadow pretty quickly. But the fun really begins at 06:26:06 UT. The moon is now entirely within the Earth's umbra. If you've been watching the gradual encroachment of the shadow, you'll see the last sliver of bright, direct sunlight fade away, leaving the moon bathed in an eerie reddish glow. But why does the moon turn red? It's because of the Earth's atmosphere. While direct sunlight is blocked, some light still filters through the atmosphere and bends around the planet, scattering shorter blue wavelengths and allowing the longer red and orange wavelengths to reach the moon. Essentially, the moon is being illuminated by all the sunrises and sunsets happening around the Earth at that moment. The intensity of the color can vary. Some eclipses produce a deep, blood-red moon, while others appear more coppery or even brownish. Factors like volcanic activity, dust, and atmospheric conditions on Earth play a role in how much light reaches the moon. During totality, the moon won't be completely uniform in color. You might notice darker and lighter areas caused by variations in the density of Earth's shadow. If you have binoculars or a telescope, this is a great time to take a closer look at the moon's surface, as the contrast allows certain features, like the maria and craters, to stand out in an unusual way. This phase lasts for an hour and 5 minutes, giving you plenty of time to soak in the view. It is also one of the best moments for photography, as the reduced brightness makes it easier to capture details without overexposing the image. If you're watching from a dark sky location, take a moment to glance around. The sky may appear darker than usual, as the full moon's usual brightness is significantly diminished. This can make fainter stars and deep sky objects more visible than they'd normally be during a full moon. Enjoy the show, because the moon will slowly begin its journey out of the Earth's shadow, gradually brightening as it moves toward the end of the eclipse. At 07:31:26 UT, the moon starts to emerge from the Earth's umbra, gradually returning to its normal brightness. At 08:47:52 UT, the umbral shadow leaves the moon's surface completely, and at 10:00:09 UT, the subtle penumbral shading dissipates, ending the eclipse. Remember, while the penumbral phases are subtle, the partial and total phases offer a spectacular show. Weather permitting, this event will be visible across all of North America and most of South America, providing a perfect opportunity to witness the beauty of a total lunar eclipse. There are no major meteor showers or comets visible in March, as this is being recorded. Here's a quick space mission update. The Firefly Blue Ghost lunar lander is in orbit around the moon and is scheduled to land near Mare Crisium on March 2nd. On March 12th, SpaceX will launch the Crew 10 mission to the ISS. A Dragon that has been at the station since September of 2024 will return in late March or in April with Sonny Williams and Butch Wilmore, who've been on the ISS since June. SpaceX may also launch Starship Test Flight 8 in March, although the date hasn't officially been posted yet.
Now it's time for the
Lunar Feature of the Month. This month, let's explore the lunar crater Cassini. The crater Cassini is named for the Italian-French astronomer Giovanni Domenico Cassini, who lived from 1625 to 1712. He is best known for his work in planetary astronomy. Cassini made major contributions to our understanding of Saturn, including the discovery of 4 of its moons and that large gap in Saturn's rings, which we now call the Cassini division. He also made significant advancements in lunar and solar observations, mapping the moon in great detail for the time. The crater is also named for his son Jacques, who worked with and contributed to much of his father's work. Cassini measures about 35 miles, or 57 kilometers across. Because its floor is almost completely covered in ancient volcanic material, it has a dark, flat appearance, similar to the nearby crater Plato. Inside Cassini, there are 2 prominent impact craters, Cassini A and Cassini B. The larger of the 2, Cassini A, is about 9 miles or 15 kilometers across and stands out nicely when viewed through a telescope. Cassini is located near Montes Alpus, the Lunar Alps, and the Alpine Valley, Valles Alpus, making it an excellent landmark when observing the moon. Nearby, the more traditional impact craters Aristillus and Autolycus create an interesting contrast with Cassini's smooth, lava-covered floor. Cassini is an ancient crater that formed over 3 billion years ago during a period of intense bombardment in the moon's early history. But instead of keeping its rugged shape, massive volcanic activity later flooded the crater, burying its original floor under a layer of dark basaltic lava. That's why instead of the jagged walls and central peaks like you'd expect from a crater of its size, Cassini has a relatively smooth floor with only a few impact scars. The crater has been a reference point for lunar explorers and astronomers for centuries. It's not far from the Apollo 15 landing site, where astronauts David Scott and James Irwin explored the Hadley-Apennine region in 1971. Cassini is a fun target for small telescopes, especially when the sun is low on the horizon. The best time to observe it is a few days after first quarter or just before last quarter, when the lighting creates shadows that highlight the subtle details in the crater. So when you're out observing the moon, make sure to give this unique crater a look. Okay, now it's time to leave the solar system. Let's explore some of the deep sky gems in the constellation Leo the Lion. As we stated earlier, March is the unofficial start of galaxy season. Leo is well placed in the evening skies in March, and it holds a lot of galaxies that are within reach of amateur observers and imagers. Our first target is actually a 3-in-1, so let's explore the famous Leo triplet. This trio of galaxies, M65, M66, and NGC 3628, lies about 35 million light-years away and offers an incredible look into a small group of galaxies that are interacting with each other. Even through a small telescope, you can spot M65 and M66 pretty easily. Both are bright spiral galaxies, with M66 being the brighter of the two. In my 8-inch SCT at low power, M66 reveals faint dust lanes and a hint of spiral structure, while M65 looks a little more subdued with a smooth, elongated shape. But the real challenge, and one of the most rewarding views, is NGC 3628, often called the Hamburger Galaxy because of its thick, dark dust lanes slicing across its face. It's dimmer than M65 and M66, so it needs darker skies to really stand out. In my 8-inch Dobsonian from a very dark sky in Vermont, I was able to see the Hamburger as more than just a dim, cloud-like line. The dust line can be spotted, but it takes patience, good optics, and a very dark moonless sky, and averted vision in most cases. One of the things that makes the Leo triplet so fascinating is that these galaxies are interacting. Over millions of years, their gravitational influence has distorted their shapes, triggering bursts of star formation and stretching out tidal tails of stars and gas. In fact, that thick dust lane in NGC 3628 is likely the result of interactions with its neighbors. M66 is the brightest of the three spiral galaxies. It glows at magnitude 8.9 and spans 9 by 4 arc minutes. M65 is a bit fainter at magnitude 9.3, while spanning 9 by 3 arc minutes. The Hamburger Galaxy, named so as that's kind of how it looks in long exposure images, where it shows an edge-on spiral bisected by a dark dust lane. It glows at magnitude 9.5 and spans 13 by 3 arc minutes. To find the Leo triplet, start at second magnitude Denebula, the bright star marking Leo's tail, and sweep toward the third magnitude star Chertan, or Theta Leonis. Then sweep south 2.5 degrees, and they'll be just to the east of center in your eyepiece. Our next three objects can also be seen in a single view with telescopes that give a wide field of view at low power, sometimes referred to as a rich field telescope, or RFT. Let's explore them one at a time. I've seen this in a single eyepiece view using my 8-inch Dob with a 20mm Nagler eyepiece. That gives a field of view that's almost 1.8 degrees wide with a magnification of 45 power. And from dark skies, they're actually pretty easy to see, even with my 70mm refractor. They're sometimes referred to as the M96 group, or the Leo 1 group, named for M96, which is the brightest of the three at magnitude 9.2. It's cataloged as a double barred spiral galaxy, but visually it appears as an elongated glow, brighter toward the center, that spans 8 by 5 arc minutes, although visually it actually appears a bit smaller as the outer sections are very faint. About 3/4 of a degree east of M96 is where you'll find M95, a barred spiral galaxy that's slightly fainter at magnitude 9.7, while spanning about 3 by 3 arc minutes in size. Visually, M95 looks like an elliptical galaxy, diffuse around the edges while the light gets a little more concentrated towards the center. Located about 3/4 of a degree north of M95 is where you'll spot M105. This is an elliptical galaxy that glows at magnitude 9.3 and spans about 5 by 5 arc minutes. Visually, it appears as a diffuse glow that's brighter toward the center, but it doesn't really show much detail at all. There are several other fainter galaxies that are members of this group. Just a few arc minutes east of M105 is the 10th magnitude spiral galaxy NGC 3384, whose core can be made out pretty well. The other members are more spread out, but are in the same general area. Locating the Leo 1 group is actually really easy. Imagine a line from Chertan to Regulus. About halfway along that line is a 5th magnitude star. Sweep just over 2 degrees south of that star, and you'll be looking at the Leo 1 group. Our Deep Sky Challenge object for March is another interesting trio of galaxies in Leo. In his book, Cosmic Challenge, Phil Harrington refers to these as the Leo Trio 2, but I haven't seen that designation anywhere else. I like it. Hopefully the name will catch on. Like all of Phil's books, Cosmic Challenge is a great read about many lesser-known but still interesting objects and can be a huge help in planning observing sessions while growing your skills as an observer. The Leo Trio 2 is comprised of NGCs 2964, 2968, and 2970. The 3 galaxies are pretty small and fairly faint, but they appear very close to each other, with the 3 galaxies fitting in an area about 10 arc minutes wide. The biggest and brightest of the trio is the spiral galaxy NGC 2964, which glows at 12th magnitude and spans almost 3 by 1.5 arc minutes in size. It's located about 60 million light years away from us. Located just 5 arc minutes northeast of NGC 2964 is NGC 2968, a spiral galaxy that is glowing at around magnitude 13 while spanning 2.2 by 1 arc minutes. It's closer to us at about 46 million light years away. Just 5 arc minutes to the east-northeast is the elusive NGC 2970. This elliptical galaxy glows faintly at magnitude 14.7, while spanning a mere 36 by 24 arc seconds in size. Seeing this is a real treat, as it lies around 120 million light years away. I've observed this group in my 8-inch SCT with a 20mm Nagler eyepiece from a dark sky site in New Jersey. NGC 2964 appeared as a faint oval glow with a brightening at its center. NGC 2968 appeared much smaller and fainter, and essentially looked like a small featureless glow. Unfortunately, I wasn't able to see tiny NGC 2970. However, I have seen it through a 12-inch scope, and my notes state that it resembled a very faint star. There is a 12th magnitude star located just 2.5 minutes west of NGC 2970 that you can use to help you find it. Using averted vision was necessary for me to pick it out, so a larger scope combined with dark moonless skies will help you to spot this challenging trio. While it may be difficult to see, the trio is easy to locate. Start at 1st magnitude Regulus and sweep north about 14 degrees to the magnitude 3.8 star Rosalis, also known as Mu Leonis. This is the northernmost star of the Sickle asterism in Leo. Follow that line in the same direction for just over 6 degrees and you'll spot the Leo Trio 2. I hope that you'll take a shot at locating these elusive galaxies and that these objects become favorites of yours as well. Well, that's all for this episode. Thank you so much for joining us, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please do all those podcast YouTube things, such as like, subscribe, comment, and share. It really, 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 really helps us. If you'd like to support the Astro Guy podcast and YouTube channel, you can do that by just buying us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you again for joining us, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zuhl, and this was the Astro Guy podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.